Okay? We do that in maths. So we have this term and that term. And when we want to find the velocity, what do? We differentiate this, and we add to, we multiply by that, then we differentiate that, and we multiply by this. Are we together?
Yes.
Let's do that. If we differentiate this part here comes there, which means it will be A times that plus that times B. Okay? Then we add to the normal AB. And then when we differentiate this on the other hand, this one, let's call this to simplify matters. Let's call this omega what? Omega D. Cos omega D T. Sine omega D T. So we are going to say this is equal to e to the power that minus zeta omega n t. Now, for the cos term, okay, let's just put it as it is. Let's do the first one. It will be minus zeta omega n a cos omega dt plus b sine omega dt. So this is this derivative of this times the bracket. Now let's take that times the derivative of this plus. We differentiate that, we get minus omega d a sine omega dt plus omega d b cos omega dt. And we add up. So we add the sine terms on their own and the cos terms on their own. Can we still see if I write at the bottom? We can't see at the bottom. But this one, are we seeing this one? Okay, let's write it at the top, the final expression for the velocity is equal to e to the power minus zeta omega nt. Now for cosine, we have a that plus omega. For cos, we have a that and b that. So let's add them. We have omega dt, not with the t, omega d, b minus omega n cos omega dt. Right? Then we do also for the sine, we have that with a b and that, and both of them are being subtracted. So we can subtract outside, then we say omega dA plus zeta omega n sine omega dt. And then having found that, you can all go on to find the acceleration, and you do exactly the same thing. Are we together?
Yeah.
In other words, you do this one, you write the expression like that, then you do inside, and then you add up again. Are we together? I have a question. Suppose you get a question which says, find the what? The displacement x at any time t. Any x at any time t is simply x, but you are just doing that. And this is the same as that. The t here is to say it's an expression where the variable is t. Even if I didn't write it, you can see the variable is t, isn't it? So even if I write it this way without putting the bracket and t, and I leave it like that, you can see already, because you can see the t, there is the t, there is the t. So to say xt, that means x with a variable t. I'm only giving further information there, which I didn't give there. But it's the same thing. Is that clear?
Now, a question comes, suppose you are told a system is M is equal to 10, K is equal to 5,000, C is equal to 200. Okay, with the proper whatever. With the proper, what do you mean? I mean, units. Then I'm saying, find the displacement of this thing at any time t. What are you going to do? How do you answer that? Now we are going where people really... What do you do?
You create that equation.
You create this equation, eh? And then you solve like that. Because basically what you are trying to find is to find the value of A and B. And for you to solve for those, here we have an expression for the x, and there the velocity. Now you now use your initial condition. So if you are given x naught, the initial displacement, you substitute it into this expression. Then what you find is cos 0, because you are taking everything at time t is equal to 0. That's the initial point. As you start, time is 0.